Hey Seema, how are you doing?
I'm doing good.
Mm-hmm.
How are you?
Doing good as well. Doing good as well. I
Mm.
believe today is your first session, right?
Yeah,
Okay, so not to worry. Like we had one or two sessions. I'll share the recordings with you.
okay.
So, like before the rest of the guys join and we start with the usual day.
Mhm.
Could you just, like share your journey so far, the things that you have done, the kind of projects that you've handled, if any work experience you have?
I have worked back in India in an insurance company for almost 9 years and then came here for my MS program in 2022.
Okay.
So I did MS in data science and I have learned Python, SQL, machine learning, and a lot of SAS actually. And we had an course program with one of the companies, as in it's like internship, but we won't get paid. It's part of the coursework. The
Mm-hmm.
company we did the sales analytics of the company called Lightcast here. So we had that opportunity, and I worked as graduate research assistant throughout
Okay.
the 16 months. And we did a lot of projects in Python and machine learning and R. I mean, each one.
Okay, okay. And what brings you to the training program since you're already well conversed with Python machine learning? So, what brings to this training program?
Because it's taking long, and since I am a newcomer to data, whatever, even a data engineer, I just want to brush up all that because I have studied long ago. I have masters in software
Hmm.
engineering and IT too, but I have studied those long ago.
Yeah, but this
And
this I hope you are aware that this particular training is on primarily on machine learning with Python. I hope you know
y-
that, right?
yeah, and you had asked me to get training in Power BI and SQL, which I did. And
Mm-hmm.
they asked me for ETL. I said, I don't know ETL. And that guy was telling me to get training. And I sent an email and they gave me this link. And I told them I have learned machine learning a lot. But still, they sent me this. I don't know.
Okay, not to worry. I'll have a word with them and we'll try to figure out that. Whether you should be a part of this cohort or not, because like I don't really want you to go through the same thing that you have already gone through a lot of times, right?
Yeah, I know
uh,
ETL. Yeah.
yeah, great.
So today, should I join or
Yeah,
you
yeah,
want to?
absolutely, absolutely. There
Okay.
is there, I
Okay.
mean, like, even if you have gone through a lot of things, it's absolutely fine even if you are a part of this cohort. Okay. Because like probably you can get a lot to go, something new to learn as well. Okay.
Yeah, and it's been four
So
months too. Oh, I would have
So
forgotten.
from my aspect, from my perspective, like from my side, absolutely there is, like no problem if you're a part of this cohort. I just want to
Mm-hmm.
make it sure that, it is adding value to you. Okay, it's not the same thing that you have learned before. Okay, so that's the only concern I have. Okay, nothing
Okay.
else. For that, I will definitely follow up with the team and we'll figure out. And if required,
Okay.
like I will ask the team to, to schedule a one-to-one between you and
Yeah.
me so that we can
Okay.
understand it better. Okay.
Okay. Yeah, sure. Thank
Okay, great. Hi Mohanraj and hi Abdul. How are you guys doing?
Yeah, good. So yeah, doing good. Thank you.
Great, great, great. Okay, so let's dive in. So on the last day, we had a kind of overview to the, you know, this spectrum of data science, and we try to understand different facets and different cornerstones of this particular domain. Okay, now today what we're gonna do, we will take one step further. We will, look into the role of statistics in data science, or you can replace this data science with data analysis, machine learning, anything, like for any role pertinent to data. Okay, what is the role of statistics? The reason is, there are a lot of theories which are doing rounds these days that since computer science have evolved so much, and now we are working with large amount of data, so probably we don't really need statistics because a lot of statistics, a lot of statistical models, or a lot of statistical techniques are based on a lot of assumptions. So probably it's better if we leave out statistics and work with high-end algorithms. Okay, but that is not the case. And the purpose of this session is not to validate anything. The main purpose of this particular session is we should know that how to leverage statistics and what tools and techniques or what methodologies in statistics that probably we have learned earlier, we have studied earlier, can be used in in uh, pragmatic data analysis. Okay, which will help us to be a better professional when it comes to the role of data analyst or uh, data scientist, whatever. Okay. So great. So having said that, uh, what do we mainly implement statistics, if you ask me? So statistics. So we mainly implement statistics in data engineering. Sorry, in data understanding. Okay. So if you remember, so if you remember, in the last day, what we did, we tried to understand different steps of data mining, where we discussed, business understanding, data preparation, model development, model evaluation, then the deployment. Okay. Now, in this entire spectrum, okay, we use statistics mostly when it comes to data understanding. Okay. Now, when it comes to data understanding, there are three aspects of data understanding. So what are they? One is 1, 2, and 3. So the first is the data engineering. So this is also a part of data understanding. Why? Because we try to understand how the data is being stored across different databases within the organization. Also, what kind of data we might require from the external databases and how to store them so that we can leverage them or we can consume them for further activities pertaining to data analysis. Okay. Followed by data quality, to check the data quality. Okay. This is another um, aspect of data understanding, to check the data quality. And then the third is the data relationship. Okay. So out of these three, we require statistics in these two phases when it comes to data quality and data relationships. Because data engineering is all about creating pipelines and all these things. So, uh, we do not really need a lot of statistics as such, okay, over there. But when it comes to data quality and data relationships, okay, we need statistics a lot. Okay. Also, why do we need statistics is in data preparation stage. Okay. So we need statistics in data preparation stage. So what do we carry out in data preparation? So in data preparation, we mainly carry out focus on two things. One is we carry out a lot of transformations. Okay. And we carry out a lot of feature engineering. Okay. Now, when it comes to the involvement of statistics, so statistics is mainly involved in this transformation. Okay, it is not that involved in it. I mean, like we do not really involve a lot of statistics in feature engineering. Rather, we focus on a lot of machine learning techniques. Okay. But stats, we use them in the transformations. Okay. For example, scaling in those areas. Okay. So that being said, let's dive deeper and let's try to understand uh, how like stats play a major role across these areas. Okay. So great. So what I'll do, I will uh, present this particular picture now, that we have statistics, or let's say we have role of statistics. That is where we are focusing, and I will make over here three. We use three, like mainly three areas where we use statistics. So one is like the data quality, another is data relationship, and the third one is data transformation. Okay, great. And out of these, like these three, we know that the first two are coordinated data understanding stage, and the last one is for the data preparation stage. Great. Now, with that, let's also try to understand that, like which part of statistics we use where, because, like when it comes to statistics, we know that there are primarily two branches of stats. Okay. So if I write over here stats, so primarily there are two branches of statistics. Okay. So what are they? One is descriptive statistics and another is inferential statistics. So one is descriptive stats, and another is inferential stats. Okay. Now we use descriptive stats to understand the data quality and also to carry out the data transformations. Whereas we use the inferential stats to understand the data relationships. Okay. So it's important for us to understand this particular picture even before we go ahead and start talking about the technicalities. Why? Because we have read a lot of formula, we have come across a lot of formulae, we have done a lot of maths. Okay. However, I mean, like there is still, I believe, there is a lot of gap in understanding where to use what. Okay, or how we can leverage a lot of things that we have learned so far from the academic point of view. Okay. Great. So let's now focus on each of them. Like we talk about the descriptive statistics. So what is, like descriptive statistics? So for example, we have got, we always work with a sample. We do not really work with the population data. So we work with the sample. Now, when we work with a sample, we need to understand what kind of sample we are working with. Okay. So even when, like we go to a new place, let's say, okay, so we come across new people, new culture, everything. Now, oh, sorry for this. So we come across new people, new culture, a lot of new things for us. Okay. Now we cannot really, be judgmental of that particular place or people, or we cannot really, understand everything uh, during our short stay in that particular place. So what we can do, we can always, take note of the things that happen around us, and we can consider it as a sample, and then probably we can try to understand what kind of sample we are working with. Okay, the same thing happens with the data. Okay, so when we get the data for the first time, it's a new data for us. It doesn't matter, like whether we have always worked on that particular domain or not, but still every data is new. Okay, so in that case, what we do, we try to understand the data that we have got with a sample, and we try to understand the sample characteristics. And the descriptive statistics is all about how we understand the, understand the sample. Okay. So in descriptive statistics, what we have, again, there are two measures that we use to describe any data. Okay. So what are they? One, we use the measure of central tendency, and another is we measure the dispersion. So we measure of central tendency, and on another side we have the measure of dispersion. Okay, so we use these two measures to understand any sample that we have. Now, measure of central tendency, this deals with the central value for any variable. Okay, so this deals with the central value for any variable. And measure of dispersion, this helps us to understand the consistency of the data. Okay, so measure of central value means where the balance is located, where the fulcrum of a particular variable is located. Now, when it comes to measure of central tendency, we know that there are primarily three measures of central tendency, right? So we have primarily three measures of central tendency. What are they? We have the mean, we have the median, and we have the mode. Now, as we know, mean is, the sum of all the values divided by the number of items that we have in our particular sample. Median is the position on average when we take the data in a chronological order. And mode is the, the often repeated values. Okay. So now the question comes, where to use what? Now for that, what we do, we try to understand how many types of data we have. Okay. So if you look at the types of data we have, so I'll map it with here. So we have primarily two types of data. Okay. So what are they? On one side, we have the categorical data. On another side, we have the numeric data. Okay. So we have categorical data. So we have categorical data and we have numeric data. Now, even if we talk about categorical data and numeric data, there are further classifications that we can carry out. So, for example, even in categorical data, we have further, nominal, and ordinal. And when we talk about the numeric data, we also have further classifications. Like count, and we have continuous. Okay. Now, what is nominal data? Nominal data is the categorical data that we use to encode any value. So, for example, when we encode, like gender with 0 and 1, so there is no specific importance that is being attached to any particular gender. Or let's say when we give, any encoding to ethnicity. Okay. Again, there is no importance being given to any ethnicity. Okay. So we can encode it in any way. Same goes with city, same goes with a lot of things. However, ordinal is where these encoding hold a significance because it gives us a particular rank. So for example, when we talk about Likert scale, okay, 7-point, 9-point, 11-point Likert scale, because as we go towards towards a higher side of the Likert scale, that means a positive feedback or a positive sentiment towards something being asked, towards attitude. Okay, or even if we talk about the age group or income group, in those cases, the ordinal is a rank kind of thing, which tells us that, okay, like a particular value will hold a particular importance. Okay. On the other hand, when we talk about the numeric count is, we talk about the finite count. When we talk about the count variable, these are those variables on which we can use the probability mass function. We do not really need we cannot use the probability density function. Okay, so we talk about the finite count. For example, let's say number of accidents happening at a place, or number of fraud transactions happening for a bank in every month. Okay, because the numbers would not be too high. Okay. However, if we have very high count values, for example, a number of visitors at a popular YouTube channel. Okay, a channel like StatQuest by Josh Stammer. If anyone is interested, then please visit this YouTube channel. It's a fantastic YouTube channel to to get yourself acquainted with technical part of the statistics from someone who is who is great in the industry, who is one of the stalwarts in the industry. So StatQuest by Josh Stammer. Okay. So if we look at the number of visitors at his website, okay, sorry, at his YouTube channel, the number is quite high. It goes in millions. Now, when it goes in millions, we are not interested in the probability mass function. We are interested in the probability density function. That what is the probability that there would be somewhere between let's say 200,000 to 210,000 visitors on one particular day. Okay, we will not be focused on, okay, what is the probability that there would be exactly 211,000 people visitors at his channel. Okay, so we are focused on the probability mass function. So in those cases, we consider them as continuous data, which is also like the measured data. So measured data means where we do not count, we measure. For example, when we talk about age, weight, height, any variable that has got some units, they are all measured data. Okay. So any data which is not measured and yet they are continuous variables. Yes. For example, when we talk about high count variables, they should be treated as continuous variables. And also when we have the percentage data. Okay. So percentage is also continuous. They are not count because we have to measure the percentage and it can take any value on the scale. Okay. So that being said, when it comes to the measures of central tendencies, where do we use what? So we always use mode, when it comes to nominal data. Okay, when it comes to nominal data. Now, if we talk about the ordinal data, so for example, we talk about the Likert scale, we have asked, a response. So for example, if I ask you to rate between 1 to 10, okay, on, 1 to 10 for this training program, or let's say, uh, yeah, so 1 to 10, the rating that you will give. Okay, so definitely it's your attitude uh, towards the training. So it will be the ordinal data. Now, in that case, if I go ahead and try to find the measure of central tendency, should we use mode? Uh, we can use mode, but probably, median can be a better choice because we can arrange the data in a chronological order, okay, which will hold a lot of sense. Okay, even in that case, if we arrange the, the ordinal data in a chronological order, it will make a lot of sense. And probably uh, we can use median. Median can be a better choice as, as a measure of central tendency. And definitely when we talk about count variable, also median is a better choice. But then sometimes you can also use count, count variables uh, to be like categorical variables, where when we talk about the number of bedrooms, let's say for an apartment, we are talking about the number of bedrooms we have. Now, definitely, number of bedrooms, if you look at the number, it's count. Okay, we count how many bedrooms we have. Now, uh, from another aspect, if you look at, you can consider the one bedroom apartments as the studio apartment. Now, when you have the two, three bedrooms apartment, you can talk about it as uh, a basic apartment. And four-bedroom apartment, like 4 to 6 bedroom apartments can be luxury apartments, and 6+ can be ultra luxury or something like that. You can deal with them as categorical variables as well. Now, if you categorize them, then definitely mode will again become your go-to, you know, like your go-to measure of central tendency. Okay. Otherwise, median is good to go ahead with. So I'm sticking to median because that is, like I'm going by the rule book right now. However, what I'm telling you as well is uh, different approaches, because when you work with the data, you will find that you cannot go with the rule book. There are a lot of times when you have to modify the rules and you have to find your own rules. Okay. And that is why I always say that when we talk about data science, when we talk about analytics, there is nothing like any thumb rule. Okay. So we can approach a particular problem from multiple sides. Okay. And it all depends on how do we approach a particular problem. So there is nothing called this is right and this is wrong. Okay. It's all about your approach and someone else's approach. And at the end of the day, the approach which works better is the right approach, and the approach which is not working up to the mark, we need to modify that approach. Okay. So there is, nothing like we have to follow this in this scenario. No if else kind of thing over here. So when it comes to median, I will, mention it over here that we go for ordinal data, and also we go for the count data. Okay. Now I have kept one area still blank. Why? Because when we talk about continuous data, okay. So for the continuous data, uh, definitely the go-to measure of central tendency is the mean. Why? Because it takes the sum of all the values and it divides by the number of items. So mean is the absolute representation of the entire sample. Okay. However, the problem with the mean is, as we know, that it gets affected by all the extreme values. So if there are like extreme values towards the right or towards the left, then the mean will also be affected by them. Okay. And that is the reason why, like we should be careful while using the mean. So if, like uh, we are working with continuous data, which follow a kind of normal distribution, or where there is, like the distribution is okay to go ahead with, even if it is not following normal distribution. Okay. It's still okay to go ahead with. We should use mean. However, if the distribution is, like too much skewed, or there are a lot of, like outliers in the data. Again, the word that I have used, the phrase that I've used, too much of outliers, that is not right. Uh, because that we'll understand in the upcoming sessions. Why? Because, like when we talk about too much of outliers, that means they are still part of the distribution. They, like outliers are rare to encounter. So if we have outliers in the data, in that case, we should go ahead with the median first. And then once we normalize the data and we take care of the inconsistency, then we should go ahead with the, like the mean. So what I'm doing over here, for to use mean, I am mentioning over like consistent continuous data. Okay, so I'm mentioning this term like consistent. Uh, I know you will understand this, consistent continuous. However, we go with the median when we have continuous, like so when we have continuous data, but when it is inconsistent. So I'm writing inconsistent continuous data. Okay, so this is something that as a first thing I wanted to discuss, like which measure of central tendency to use where. Okay. Now, when we talk about the consistency, the measure of dispersion, what are the different metrics we have for the consistency? So I will, like mention the most important ones. So okay, so quite a few. So what are they? First one is definitely the standard deviation. The second one is variance. The third one is Q1, or the 25 percentile. The fourth one is Q3, or 75 percentile. The fifth one is Qness. And the sixth one is kurtosis. Okay, so we use all of these metrics to understand the consistency of the data. How? Standard deviation tells us on an average how far away the data points are from the central value. Okay, so if, like we get standard deviation to be 13, okay, let's say we have got average age, let's say mean age, we have got to be, like 40, and we get the standard deviation for age to be 13, then within one standard deviation, we will have people lying from 27 to 53. Okay. Now, how this is important? Because if the standard deviation is low, then what will happen? Your range will be robust. Okay. And if your range is robust, for example, if your standard deviation is not 13, but it's 3, then within one standard deviation, you will have 37 to 43. Okay. So that is much more robust. It is easier to find points within here. Okay. It is easier to predict even. However, if it is 13, then what happens? Your range becomes higher and it becomes more difficult to find consistent points. Okay. Because 27 on one side and 53 on another side is huge. Now, if you look at two standard deviation, then what will happen? On one side, you will have 14. Okay. 40 minus 26. 14. On another side, you will have 66. Okay. So again, a huge range we have to work with. So standard deviation always gives us a kind of impression that, okay, how consistent our data is going to be. Less standard deviation, great. High standard deviation, not that desirable scenario. Now, when we talk about, but then how to use these metrics to understand the quality of the data, I'll also talk about it. Now, when we focus on variance, okay, so variance, mathematically speaking, it is just the square of standard deviation, okay, but that is not its only identity. This is where, like I really find a lot of gap in, in the textbook of statistics. Trust me, when I was uh, at the university, okay, this question was always in my mind that, okay, standard deviation is square root of variance. Variance is square of standard deviation. Then what's the point of, like having both of them at the same place? Okay. But then when I started working with the data, what I understood that a lot of key concepts we talk about in handling the data, they all depend on the variance, not standard deviation. So for example, you talk about ANOVA. Okay, so what we do in the ANOVA, we find out, we split the total variance into between group variance and the within group variance. Now between group variance is the variance captured across the groups, and within group variance is the amount of information stored within a group. Okay, so variance is also, like it, and eventually if you look at any dimension reduction technique like principal component analysis, factor analysis, we always focus on that the amount of variance captured after, like reducing the number of dimensions should be equal to the amount of variance that being captured by the original number of features. Okay, so variance is not only it's not it's I mean, like, it doesn't really have a single identity of being square of standard deviation. Rather, it can also be perceived as the amount of information being like being stored or being captured within the data set. Okay, even if you look at it from that perspective, that is a rule of variance. Q1 is 25 percentile. That means if we say that, okay, Q1 is, let's say in this case, we say Q1 is 20. What does it mean? That 25%, 25 percentile of the sample, their age is less than 20. Okay. Similarly, we talk about Q3, and let's say Q3 is 70. That means 75% of the sample lie below 70, and 25% of people lie beyond 70. Okay. Again, how to use this? We'll talk about that. Skewness. If the so like to understand skewness and kurtosis, let's have a look at it. So when we talk about the distributions, so primarily there can be three distributions that a data, a particular variable can follow. One is this, which is a symmetric distribution, okay? And we also call it as a normal distribution. On the other hand, the distribution can follow a shape like this, where we have a longer tail towards the right, which is positive skewness. And then we can also have a distribution like this, where we have a longer tail on the left, which is negative skewness. So if you look at this, this is positive skewness, positively skewed. And how do we find out? The value of skewness will be quite greater than 1. Okay. This is normally distributed. Okay. And over here, the skewness will be in and around 1. Okay, it will not be exactly 1. It can be less than 1. It can be greater than 1, but it will be in and around 1. Okay. And then this is negatively skewed. Okay. And in this case, the absolute value of skewness, or let's say if I write skewness, it will be greater than -1. Okay. So there would be a sign, negative sign. Again, like if you look at these skewness, you will find that in the first case, mean will be quite greater than median. Okay. In this case, mean and median will be compatible. They will be quite close to each other. And in this case, median will be quite greater than mean. Okay. So again, you can understand the skewness of the data from the measure of central tendency as well, because we always try to understand the data from multiple, like vertices. And when we talk about kurtosis, it is also about the peakedness. So if we find that the data is quite peaked, it is quite peaked. So what does it mean? In this case, you will find like if you find the kurtosis of any variable to be greater than 3, that means there are a lot of data points towards the end of the distribution. And remember, if there are data points towards the end of the distribution, that means they are extreme values. Similarly, when we talk about skewness, they are extreme values, because if your data is positively skewed or negatively skewed, that means a lot of data points are present either on the higher side or on the lower side, respectively. Okay, so now the question comes, how do we use all these metrics to understand the quality of the data? So we can, first thing is, when we talk about quality of the data, the first thing we are interested in is the missing values. So when we have missing values, what we can do, how to handle them? Either we can drop, okay? Either we can drop them or we can impute them with mean or median. And I'm not writing mode because we seldom use mode. Okay, so that is one way of, of using the measure of central tendency to handle the missing values. Second, to understand the distribution of data. To understand the distribution of data, what we can do, we can first look at the mean and median comparison. We can look at the mean and median comparison. Okay. Second, we can look at the skewness, and the third, we can look at the kurtosis. That can give us a fair idea about what kind of distribution we are working with. Also, before this, I will mention the standard deviation. Okay, it can also give us an idea that whether the data is going to be quite skewed or not. So now, after that, we have the outlier handling. So in the case of outlier, okay, though we will have a separate session on how to handle the outliers and all these things, but still, for now, let me mention this. To handle the outlier, what we do, we find, we first look at Q1 and Q2, Q1 and Q3, and then we find IQR. What is IQR? IQR is interquartile range, which is Q3 minus Q1. Okay. So IQR or interquartile range, which is Q3 minus Q1. And after that, what? We find a threshold multiplying this IQR by 1.45. Okay. And then a statistical outlier is any value which is less than this Q1 minus IQR multiplied by 1.45. Okay. or if a value is greater than Q3 plus IQR multiplied by 1.45. We call them as statistical outliers, but there are a lot of like caveats into this. What are they? We will understand them. Okay, in the due session where we will handle the outliers, we'll have a separate session on missing values, and similarly we'll have a separate session on outliers. Okay, so any data point which is over and beyond like these data points, they can be called as outliers. So this is how we can use the measures of central tendency to assess the quality of the data. Also, when we talk about transformation, okay, so in transformation, there is one particular technique of scaling. Now, when we scale the data, either we can go for standardization, okay, which is a process of standardization, which is a process of converting a given distribution into SND. SND means standard normal distribution. So how do we do that? We subtract from a value, let's say xi, we subtract the mean of x and we divide this by the standard deviation of x. Okay. This is one way. Second way is normalization. So what happens in normalization? We convert all the values between 0 and 1. And how do we do that? We subtract the minimum value from every value and we divide it by the range. Okay. So again, this is how we leverage statistics in the data preparation stage for scaling as well. Okay. Now, how do we use, the inferential statistics to understand the data relationship? So a lot of times what happens from the charts and the graphs that we create, we find that, okay, there are some patterns. So for example, we might find that, the smokers tend to file for higher claim amount in the insurance, okay, as compared to the non-smokers. Now we need, or let's say people who are between 18 to 24, they tend to consume, tend to spend more on electronic gadgets rather than people beyond 25, let's say. Okay, so for example, we get these kind of patterns from the data when we are working with it. However, can we really generalize from the sample? No. For example, you go to a place and you find something weird among a few people. Can you really say, or can we really say that, okay, all those people in that particular zone are weird? No, we should have enough evidences with us, okay, to generalize. And that is where, we have this test of hypothesis. We have the test of hypothesis to go beyond the sample and to comment on the population. Okay, so what we do in the case of test of hypothesis, we have the null hypothesis, or or H naught, and we have the alternate hypothesis, or HJ. Okay, remember, null hypothesis doesn't require any kind of evidences to hold its ground. Okay, it will always talk about the ideal scenario unless some evidence is come in. So anything lesser than, greater than, anything, they have to become, they have to appear in the alternate hypothesis. They cannot be a part of the null hypothesis. Okay. Now what we do when we conduct the the test of hypothesis, there is always a probability of committing either of the two errors. So what are they? So what are the probability of the different errors that we have? The first one is we have the type 1 error. So the type 1 error, when we cannot reject the null hypothesis. And what is type 1 error? sorry, when we reject the null hypothesis. I'm sorry for that. And what is type 1 error? It is rejecting the true null hypothesis. So for example, let's say we are working on a problem where we have to identify whether a loan applicant is a probability defaulter or not. So in that case, the null hypothesis would be definitely, like the candidate would not be a defaulter. And the alternate would be the candidate would be a defaulter. Okay. And from the evidences that we have, we reject and we say that, like the candidate is going to be a defaulter. But what if the candidate doesn't default? Then definitely that is rejecting the true null hypothesis. Okay. And that is what we call as the type 1 error. And the second probability is the type 2 error. Remember, both of these are probabilities because we cannot really assess that whether we are committing the error or not. But whenever we reject the null hypothesis or we don't reject the null hypothesis, we also have to accept the result with a pinch of salt. That is, we can be wrong. And that is where the probability of the errors come into play. Okay. This is, like fail to reject false null hypothesis. That means when the null hypothesis should be rejected, but we cannot reject that. Okay. Now, out of these two, which one is easier to control? The type 1 error. Because, like if you do not reject, you are accepting everything. And that is how you can definitely control the type 1 error. You can actually minimize the type 1 error to 0. But we don't do that because that is not the right way of doing things, because we will then increase the probability of type 2 error to a large extent. Okay. So, and how do we, how do we ensure that we reduce the probability of type 1 error? By setting something called the level of significance. Now, what is this level of significance? The level of significance is our risk appetite for type 1 error. Our risk appetite for type 1 error. So for example, let's say most of the times we use 5%. That means, okay, when I'm rejecting the null hypothesis, I am okay for 5% risk, taking 5% risk in committing the type 1 error. Okay, not more than that. So what we do, we conduct a test of hypothesis and we look at the p-value. We get the p-value. Level of significance is predetermined. And p-value is something that we get from the result. Now, what is p-value? P-value is the risk of type 1 error, the risk of type 1 error suggested by the test of hypothesis. How? So for example, let's say we get a p-value of, 3%. What does it mean? If we reject the null hypothesis, then there would be a 3% risk of committing the type 1 error. Now see, if the p-value is less than level of significance, which is also denoted by alpha, it means if we reject the null hypothesis, then there is a lesser risk being involved. And that is why we say that reject H0. Okay, why do we reject null hypothesis when the p-value is less than alpha? The reason is, in that case, the risk of committing the type 1 error would be less. However, if p is greater than alpha, then if we reject the null hypothesis, then there would be a higher risk than our risk appetite to commit the null hypothesis. And that is why we say don't reject H0. Okay. Now, we use this test of hypothesis to understand the data relationship. So we find some kind of patterns among the variables. We try to be sure about that. So we conduct the test of hypothesis, and depending upon the p-value, we can say that, okay, whether the relationships exist or not. Okay, so what are the different test of hypothesis we carry out? Primarily, we carry out two types of tests of hypothesis. One is parametric. We carry out parametric when we are working with continuous data. And another is non-parametric, mostly when we are working with the categorical data. So in parametric tests of hypothesis, again, either we can use the t-test. We use t-test when we have two categorical, like when we have a categorical variable with two categories on one side and a continuous variable on another side. We go for the t-test. So for example, let's say we want to check that whether the data scientists or the data engineers get the higher salary. Okay, whether salary depends on the like data scientists or data or let's say whether the claim amount depends on smokers and non-smokers. So we have got only two categories. Okay. On the other hand, when we have got more than two categories, we go for the ANOVA or analysis of variance. So for example, if we have to figure out that whether the claim amount depends on the age group. So we have, let's say, 4 age groups, and we want to find out that whether the claim amount is related with the age group. So in that case, we go with the ANOVA, where we have more than two categories in the categorical variable. In non-parametric test, we mainly carry out the chi-square test of association, and we mainly carry out chi-square test of association when we have got two categorical variables. For example, we want to decide that whether cancer has anything to do with the smoking status. So cancer is also a categorical variable, either 0 or 1. And similarly, smoking status is also a categorical variable, 0 and 1. We want to find out that whether both of these are related or not. Okay, so there we use this. So again, we use this test of hypothesis for the data relationship. Okay, so that is what I wanted to discuss in the session today, that how we can leverage the statistics in different aspects of data mining. Okay, so what I'll do over here, I will just change this to data mining. That is more appropriate. Okay, so I hope, guys, we have got a very good picture of how to leverage statistics in the process of data mining, right? So going ahead in the coming week, we will start directly with the Python part, and from there on it will be all hands-on working with Python and the data. Okay, so great. Meanwhile, I will share the recording with you guys. Okay, so take care and have a nice day, and let's meet on the next session as usual. Okay,
Yeah, thanks,
so take care,
Keshav.
guys. Yeah,
Yeah,
bye-bye.
see you. Bye.
Yeah.